So then let's see what this looks like in real life, in an execution plan. And so here's the sample query that I've created to use as a demonstration. It's actually the same query as in the in-memory aggregation white paper. So this makes it pretty easy to go back and say, okay, so he talked about these features, and I'm now looking at the details in the in-memory aggregation white paper, and they correspond. And so we've got 3 tables. We've got our time dimension, customer dimension, and then we have a facts table. We have our join keys and a filter predicate on, we're going to look at a specific year. And we have our group by. So we're really going to sum sales and units for their time dimension based on a region. So as we start our scan of our dimension tables, remember the picture I showed you at the beginning where we're scanning the 2-dimension tables, we're going to create our key vectors, we're going to create our aggregate accumulator, and then we're going to scan our fact table, or the sales fact table in our case. So in what we see in the execution plan, I've highlighted in red the access of both the time dimension and customer dimension tables. So we're going to scan, apply any filter predicates, but notice that we also wind up creating 2 temp tables, if you will. And notice that it says cursor duration memory. That was the feature that I mentioned that was added in 12.2, so that even though they look like temp tables, these are really in-memory structures in the PGA. And hold that thought as we move on to the next. So it's the same execution plan all the way through. What I'm doing is I'm just highlighting the different aspects of that execution plan so you can kind of see where all of these activities that I've described over the last couple of slides, where these fall in the execution plan, so you can actually try this on your own queries and see what the value is for having in-memory aggregation enabled. So we're going to create then key vectors based on our scans. So we scanned our time dimension and customer dimension table, and then you'll notice that we're going to do a key vector create. KV is our key vector. We saw Bloom filters :BF in our hash joins with key vectors in in-memory aggregation. We'll see our KVs. We have 2, one for the time dimension table and one for the customer dimension table. And so we'll actually create those key vectors. Again, essentially dense memory structures. We're going to create grouping values or symbols to associate with the actual column value, so we don't have to carry that payload through the execution plan. And we'll talk about, again, that was the reason for the creating those temp tables, to capture those values so we can then reconcile them without having to go rescan the dimension tables, because our goal here is always to only touch the data once, to scan and filter that data once, and then operate and have all of the operations that we need to do to those done during that time. But notice also that we're able to go through the execution plan and create these key vectors because we have our right deep tree. We've swapped our join inputs. This isn't a traditional execution plan where we're only looking at 2 row sources at a time. We're actually, as I like to say, we're cheating, and we're pre-scanning our time dimension and customer dimension tables, and we're gonna let that flow into the rest of the execution plan. So I will move on. And then we're going to see the new access path, something called a vector group by, and that's in-memory aggregation. So you won't see that until you enable database in memory. And with database in memory, we're going to do our key vector use, very similar to what we see with our Bloom filter use. And we're going to push those 2 key vectors into our access of the sales fact table. Now notice in black I have a hash group by. Well, I don't have it. The optimizer put it in there. It's part of the execution plan. And so that's the fallback. So if the aggregate accumulator, our little picture down below the sales table here, were to get too large, we would actually fall back to a hash group by, and you'll see that in the execution plan as that's the fallback. Now, typically in a normal happy path, we're not going to make use of that, but that's there as a fallback, and so that the query won't fail. We'll just run very similar to when we don't have a table fully populated in the column store, or if the table isn't even populated in the column store, the query won't fail. It just won't take advantage of database and memory for the portions or the table that isn't populated. And the same holds true for vector group by. So the query isn't going to fail if we were to run out of PGA for the aggregate accumulator. We'll just fall back to a hash group by to finish the query. And then we see that we're going to go back. So we've done our scan of the sales table, sales fact, the fact table. We've done our vector group by. We've pushed our key vectors into the scan. The qualifying group by columns have been aggregated. And now we're going to go pick up the column values, since we have only got essentially symbols in our key vector structures. We're going to go pick up those symbols so that when we return from the query, all of the query looks just like it would look as if we hadn't used vector group by and we hadn't used database in memory. So we need to pick up all those payload columns, if you will. Typically in a normal hash join, we'd pick those up from the hash table in the PGA, but in this case, because we can have multiple grouping columns, those values could be rather large, and so we've allocated those in these temporary structures. Again, in 12.2, it's still all in memory, and so it's relatively efficient because we're only accessing those temp structures to pick up the actual columns themselves. So it's very efficient. And again, we're still getting a 6 to 8x performance improvement. Wow. All right, we did it. We did it again. We went super deep on you guys. Hopefully that I didn't lose anybody on all of that. But it is an interesting feature, and it is fairly complex. Again, I would strongly suggest that if you follow that or have any further interest in getting more details about that, that you take a look at the in-memory aggregation white paper, where this same basic example is available, and the author has gone through and explained in excruciating detail all of the different parts of that so that you can understand and take advantage of it. Of course, if you don't care about that, you don't even have to worry about it, because we'll enable this and make use of this without you having to do anything. But very often it's useful to understand some of the underlying technology associated with the features that you're making use of.